Hey folks, in this video we're going to introduce the basic concept of binary data. Binary data is going to be another way that we can store information from our programs. Now in the past we've typically used things like text in our programs. So whether we're displaying to a console or saving to a text file, it was all just plain text. Sometimes you'll also call it ASCII encoded. So just looking at my screen for a second, you'll see there's all this text up there. That's just pure text, right? Air quotes there. I see letters, right? P-R-O-G-R-A-M-S. Those are individual characters, right, in some string of text. It's plain text, right? I, as a person, can read it. Each of those maps internally, right, to something on what they call the ASCII table, right? That's why we call it ASCII encoded. The ASCII table is this table, and it's pretty big. You could Google for a picture if you want. It's this thing right here, a bunch of rows. There's basically a mapping of 255 characters to different numbers, and it says for example, A I believe matches to 65, right, or B matches to 66, so on and so forth. That's what we've been using up until now, right? So when I have my program and I see a nice console output, it's text encoded, right? It's ASCII encoded. It's just plain text. So that's what we're used to. Now, just thinking about it for a second, let's actually imagine that we're using it for something. So let's say we want to use plain text to store some information, and we want to do this in terms of a file. So you can see over here, right, I have a little sample file over here. Sample.txt, so it's you see the extension there, it's a text file. And this text file is basically just storing two numbers. So maybe we're doing something like, say, saving the size of an image. So I want to save, 152 by 152. So that's fine, right? And right now, right, you guys, if you were working in a program language of your choice, you could probably write a file that, does something, or write a program that does something simple like save these two numbers to a file. That's not too bad. So we already know how to do that. That's fine. If we do it like this, though, what happens is that when I have my file on my disk is storing those numbers, 152, not as numbers, but as characters. So there's the character 1, followed by the character 5, followed by the character 2. And then again, the character 1, followed by the character 5, followed by the character 2. Okay, so this is what happens when we have a file that is text encoded. Your file is storing character by character each little thing that you have saved in there. Okay, so that's the way things worked, and that's one thing we could do. Let's think for a second though. How much space might this take? So each of my characters, right, is actually going to be stored in 1 byte. If you think about that ASCII table, the ASCII table has 255 characters, 255 entries, I should say. Basically one of those, each of those, right, represents a different character, right? And if I want to store, 255 possibilities, well, thinking about the binary number system, basically I need to have 1 byte of data. So every character that's going to be stored in my program is going to cost me 1 byte. So this is a byte, 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 this is a byte. And actually there are a couple more bytes because there are actually characters that I can't actually see printed right there at the end. For example, the new line, right? If I want that to go down so that I have the second 252 on a different line, I need to have a new line. So I have a bunch of different things happening here. So actually, if I think about how I store this on the disk, I am actually going to take 8 bytes, which is a little bit of space. I mean, right now it's kind of our baseline, but it's a little bit of space. So thinking about that, maybe thinking ahead, you can even think, I wonder if there's a better way to store it. Because it seems like 2 numbers, maybe I could do a little bit better than storing 8 bytes. Now, before we go and talk about that in more detail, let's look at the screenshot for a second. This is a tool called a hex editor, and we'll talk about it more later on. The purpose of it is to show kind of the exact contents of a file in terms of the bytes, right? So rather than thinking about it as text, right, strings of text that you and I can read, it's thinking about it as a computer would, as these binary numbers. Or in this case, because binary obviously is a little bit hard to read, it shows it as hex values, which are kind of a convenient way to show that binary information. So let's look at this for a second. This is basically what I see when I open up my file. So I'm able to see actually the 8 bits that make up this file as it stands. So you can even see, right, that they basically have the same thing repeated twice because, oh hey, my file has the same thing repeated twice. And actually, right, if you try to break this down, what you'll realize is that 31 in hex maps to the character 1, right? It doesn't map to the number 1, it maps to the character for 1 because we're doing this plain text encoding. 35 maps to the character 5. 32 maps to the character 2, right? And these are all numbers in hex, right? So 31 is hex, 35 is hex, 32 is hex, right? And then eventually, right, this 0A, this maps to new line. So each of these values in here, right, is basically representing a byte, right? So this is right now, right, these kind of are, it's a little bit interesting to read, right? It's a little bit different than what we expect. Each of these is basically a byte. This can be a value between 0, 0, and FF. So that's 255 kind of possibilities. That's basically us representing one byte of data or one character of data in hexadecimal. So we have that there, right? And so you can see basically that we're spelling out character by character this data that I have up on the screen, okay? And you can see it's repeated there twice. On the right-hand side of the screen, you can actually see the text form as well. So this program is actually kind of cool. It shows me the binary hexadecimal representation underneath on one side and the text representation on the other side. Okay, so this is what we have so far. And this maybe seems like a little bit of space. Maybe there's a way we can do something better. Obviously, 8 bytes isn't a lot in terms of your gigabytes and gigabytes of a hard drive space. But maybe you want to think about the fact that some files could be really large. There could be a million numbers being saved. In which case, this might be a lot of space. So it's worth thinking about, maybe there's a better way to store it. And in fact, there is. We could store this data, instead of doing it as plain text, right, ASCII encoded, we could instead store it encoded in binary. So we'd store the numbers kind of directly. So rather than storing that kind of proxy, if you would, which is the characters, the individual characters, we'll just store the numbers themselves. And that you can actually see on the right-hand side. So this is the hex editor again. I can't actually show this to you guys in a text editor. The reason being that if I open up in a text editor, it's no longer text, so it'll just show me kind of some sort of like random looking characters, or maybe it'll even say, oh, this is a text file, I can't read this. Now it's basically set up so that only your machine can read it. And so we have to use this tool, right? So this is a hex editor, this is called Bliss. Basically its job is to show us that binary file format, right? To show us those bits and those bytes behind the scenes. And so that's what it's doing right now. This actually, right, you can see there's basically two things here. This is only 2 bytes of memory that we're using because we know, right, we're basically storing the number 152. And so if we store that twice, well, basically we use a byte each time, right? So this is, basically our base 10 over here, right? This actually maps to 98 in hex, right? So this is actually 152 here and 152 over here, right? Because if I have 1 byte, that's enough for me to store a value between 0 and 255. So I need 1 byte for the first entry, 1 byte for the second entry. So all of a sudden, I have all that information that I had in the text file that was 8 bytes, now in a binary file that is only 2 bytes. Caveat here is, of course, that if my number got larger, I would need to shuffle things around a little bit, right? It's pretty easy to write extra digits in a line of text. Here, because it's text, we're kind of constrained to be between 0 and 255. We need to do a little bit of legwork to get it to be larger. But right now, for these small numbers, we're definitely saving a lot of space. We're faster, or we're more efficient by a factor of 4. All right, so that's all I got for you guys in this video. Again, kind of think about this difference right of now, right? Rather than storing as strings of text, we're storing just the bytes and the bits behind the scenes, and how that basically can make things a little bit more efficient for us in terms of the storage that we use. All right, that's all I got for now. I will see you guys in the next video.